Welcome to our tutorial about bend tables. Bend tables are another way to calculate the length of your unfolded part. Basically, bend tables are created by taking direct measurements of bend parts. Now, of course, this takes more time, since you'd need to do machining with the identical materials that you'll be using. However, this is the most accurate method. It's more accurate than using the formulas. Parts which are bent less than 90 degrees and parts which are bent more than 90 degrees are measured differently, as indicated by the diagram that I put together for this chapter. As a result, the length of the unfolded part is A plus B minus the correction value. Let's go back to Inventor. I'm going to show you how we can create a bend table. I've opened a part that I created in a previous tutorial. First, let's edit the Contour Flange 1 feature. Since the A and B values are measurements of the outside bend zones, I'm going to flip the side and then click OK. Now let's go ahead and create a bend table. Click on Sheet Metal Defaults, open the Styles Editor, and expand the Sheet Metal Unfolds branch, select a rule, and now click New. Let's give it a name. Let's call it BT for Bend Table. OK. Under Unfold Method, let's select Bend Table. Since we're working in millimeters, the linear unit should be millimeters also, so let's make that modification here. Now let's add a thickness value, 1 millimeter. Let's add the bend angle in degrees, and then the bend radius in millimeters. I'll place a hypothetical value here, 0.3. This is a correction value, otherwise known as the bend deduction. If you want to insert a second row, just right-click and select Insert Row. Let's enter 0.4 here. Angle value, 60 degrees. And let's add another row. Right-click, Insert Row. Let's make the angle value 120 degrees now with a bend deduction value of 0.5. If you want to insert another column, right-click in the header area and select Insert Column. Let's change the radius to 2. And let's change this bend value to 0.35, the following to 0.45, and the last one to 0.55. We can also grab and reposition columns if we need to. Just left-click on the header and drag. Deleting a column is just as easy as adding one. Right-click on the header and select Delete Column. If you want to delete a row, you select a cell and then right-click and select Delete Row. To insert another table for a different thickness, click under the current thickness value. See, it says here, click to add. Insert the new thickness value. I've got 2. And now we just add columns and rows as we did previously. If the bend deduction lays outside the value defined by the bend table, Inventor's going to use the K factor to calculate the bend allowance. Here below, we can enter the tolerance value. For example, if our angle is defined in 4/1000ths of a degree from the angle specified in the table, that is here 45 degrees, the bend deduction value will be taken directly from the table. If the angle value lies between 45 and 60 degrees, Inventor's going to use a linear extrapolation to calculate the bend deduction value. We've got another set of options up here, bending angle reference or open angle reference. In our example, we're using a bending angle. And we're ready to click Save now. If you try to save and get an error message, your first troubleshooting stop is to check the units and angle values for errors. If you're using an open angle reference and you try to save but get an error, there may be some other reasons for this that I want to take you through in a little detail. My current sheet metal rule sets thickness at 1 millimeter. Let's change the unfold rule to table and click Save. And let's go back to our table. And let's change the linear unit value to centimeters. If I try to save it like this, I get an error message. Current thickness can't be found in the bend table. Let's cancel out of the error message. Let's restore our units to millimeters and click Save. Basically, Inventor tried to rebuild the part but couldn't find the correct values. Let's click Done. Be sure we've got Sheet Metal Rule 1_millimeters selected. The Unfold rule, we need the Bend Table, BT. Let's cancel out of the dialog window for now. And let's bring up Sketch 1. Right-click, Visibility. And let's review our formula and values. The dimension A is equal to 5 millimeters. Since we have a 60-degree angle, our bend deduction will be 0.4 millimeters, which means our unfold value will be 9.6 millimeters. And let's test it out. Let's see if our formula worked. Let's flatten the part. And now let's go to the Tools tab, Distance, select this vertex and this vertex, and our unfold value is indeed equal to 9.6 millimeters. Let's close the distance window, and let's fold our part back up. Now let's change the bend angle to 45 degrees. 45, enter. Update. The correction value for 45 degrees is 0.3 according to our formula, A plus B minus the correction value. According to this formula, we should end up with a value of 9.7 millimeters. Let's go ahead and check it. We'll flatten our part. Tools, Distance, select this vertex and this vertex, and as you can see, our value is indeed 9.7 millimeters. Let's fold our part up. If we use an angle value between 60 and 45 degrees, let's say right in the middle, 52.5 degrees, let's see what happens. Just in case you're wondering where I came up with that number, 60 plus 45 divided by 2 equals 52.5. Let's update the model now. Inventor makes a linear interpolation between the 0.3 and 0.4 correction value. The result is 0.35. This means the unfold length of the part is going to be 9.65 millimeters. Let's check it out. Let's measure. We'll flatten our part, go to the Tools tab, activate the Measure tool, select this vertex and this vertex, and that's exactly what we get when we measure, 9.65. Let's close the Measure tool and fold up our part. The last angle we've got here is 120 degrees. Let's enter 120, click OK, and let's update the part. Now let's right-click and hide Sketch 1. I'm going to create a new sketch now. New Sketch, Project Geometry, this edge and this edge, activate the Line tool, and let's create two lines here. Right-click, Done, and another line. Something like this. Right-click, Done. Now let's add a tangent relation. Right-click, Done. Let's shift-select these lines and convert them to construction geometry. Now let's apply some dimensions. Accept. The second dimension will be here. Let's accept as well. And we're ready to exit the sketch. Let's go to the Manage tab. Parameters. Let's create a user parameter. Unfolded length. Millimeters. Here we've got our A and B values, or dimensions 13 and 14. You see that they're reference dimensions. D13 plus D14 minus the correction value of 0.5. And here's the length of the unfolded part, approximately 6.57 millimeters. Let's click Done, and let's go measure and check it out. We need to flatten our part. Back to the Tools tab, activate the Measure tool, select this vertex and this vertex, 6.572 millimeters. Let's change the precision value to 6 decimal points, and let's measure again. Select the vertex and this one. And here is our value, 0.571797. And let's cancel out of the Distance tool. Fold up our part. And let's see how we can import a bend table. Let's select Sheet Metal Unfold. In Design Data of your Inventor 2010 folder, you've got a folder called Bend Tables. You have some examples of bend tables here. The bend tables are in text or Excel spreadsheet format. At the top of the files are some important annotations. One thing to note is the type of angle that the table uses, opening angle or bending angle. This bend table uses an opening angle. Okay, let's scroll down. Let's go find Table 1. Here it is. Bending radii, opening angle, and there's also bend deduction values. Okay, let's go back to Inventor and import a bend table. Click Import, File Type. Let's select a text file. Since we're working in the metric system, let's use the Bend Table Millimeters option and click Open. Inventor prompts me for a new name for the table. Let's call it BT_2, Bend Table 2, and click OK. And here is our imported bend table with two thickness values, 0.5 and 2 millimeters. You can make adjustments in the table from this interface if needed. You don't have to go back to the text file. If you want to copy and save, right-click on the empty cell header, select Copy, and then right-click and paste. Let's go paste it into Notepad. And here's a copy of our bend table. And at this point, I'm going to click Done. Let's go back to our bend table folder in the Windows directory system. You may recall that we had two bend tables in Excel spreadsheet format. Let's see how we can transfer data from those Excel tables. Back to the Style and Standard editor. Expand the Sheet Metal Unfold branch and let's select New. Let's call it BT_3, Bend Table 3, and click OK. To delete both tables, I simply select Linear, click Save, and then go back to Bend Table for our unfold method. Now, when I open the Excel file, I see information similar to what I saw in the previous text file. Down below these annotations, I've got my two tables, Table 1, and down below is Table 2. Let me copy part of this table. I'll start from this cell up here and highlight down to this cell. Right-click, Copy. Let's make our thickness 0.5. And now let's click in the table area, right-click and paste table. We've got an empty row here. This might cause some trouble. Let's delete it. Right-click, Delete Row. Let's do the same for the second table. I'm going to copy the part of the table that I want. Right-click and copy. Thickness, let's use a value of 2 millimeters. Again, right-click in the table area, select Paste Table. Let's delete this top empty row. Of course, you can copy and paste the entire table as well. At this point, I'm ready to save, and then I'll click Done. And this concludes our tutorial about creating and using bend tables.